Okay, now let's look about how we can write powers in different forms. So remember, a power is a base raised to an exponent, and this would mean this base multiplied a times. So here we have three different powers, or we call this exponential form. And I want to write it in expanded form, or we want to break it open and expand it. So what does 2 to the exponent 3 mean? Well, it means 2 multiplied 3 times. So it would be 2 times 2 times 2. Here, 3 raised to the exponent 5 means 3 multiplied by itself 5 times. So 1, 2, 3, 4, 5. And finally, 7 to the exponent 4 means 7 multiplied 4 times. So 1, 2, 3, 4. And that's called writing it in expanded form. We're breaking it from its nice compact form and expanding out into what it actually means. In this case, I want to write these in exponential form. So we're given the big long multiplication part, and we want to write it as a power, or what we call exponential form. So 4 times 4 times 4 times 4. Well, the number we're multiplying is 4, so it's base 4. Now, how many of them are there? There's 1, 2, 3, 4. So this would be written as 4 to the exponent 4. For this one, the number we're multiplying is 13. So it would have base 13 in our exponential form. Now what would our exponent be? How many 13s are we multiplying? 1, 2, 3, 4, 5, 6, 7. So we would write it as 13 to the exponent 7, writing it in exponential form. Alright, hope you've had a chance to try these. Now let's take them up. Question number 1 wants us to write them in expanded form. So we're given an exponential form, or written as a power. We'd like to break it open and expand it. So we have 4 raised to the exponent 5. So remember that means 4 multiplied 5 times. So we have 1, 2, 3, 4, 5 4's being multiplied. This next one in B, our base is 17, so we know we're multiplying 17s this time. And our exponent tells us how many of them to multiply. So that would be 3. 17 times 17 times 17. In number 2, we're working backwards. We're given the expanded form, and we'd like to write it back as a power in exponential form. So 10 times 10 times 10 times 10. Our base is 10, because that's the number we're multiplying. And there's 1, 2, 3, 4 of them, so our exponent is 4. Now this one is just the number 12. Well, we can still write it in exponential form. The number we're multiplying is 12. How many of them are we multiplying? Well, there's just 1. So it would just be a 1 as our exponent, or 12 to the exponent 1. Okay, the last part of powers we're going to look at is how we can evaluate powers. Remember in math, questions that ask us to evaluate want us to get to one final number as our answer. So we'd like to know what each of these are equal to, is really what it's asking. And the way we can do that is by writing it in expanded form first. A lot of people come to powers and they go, ooh, 5 to the exponent 2 is 10, because they just do 5 times 2. Well, that doesn't really make sense. If we wanted to write 5 times 2, we would have just written 5 times 2. Remember, the reason we created these things called power is when we're multiplying lots of numbers, lots of the same number. Remember, this means this number multiplied by itself 2 times. So it's actually 5 times 5, which is 25. Similarly for this one, 3 to the exponent 4 doesn't mean 3 times 4. We would have written 3 times 4. 3 to the exponent 4 means 3 multiplied by itself 4 times. So it really means 3 times 3 times 3 times 3. So we can evaluate this now once we write it in expanded form. 3 times 3 is 9. That 3 times 3 times that 3 times 3 is also 9. So it gives us 81. The other thing I want to talk about with evaluating is the exponent is 0. So So let's say we had 4 to the exponent 0, because this is tricky. A lot of people want to say 0, that's a lot of the answer people give, or 4 is probably another one you might be thinking of. But actually the answer is 1. Anything to the exponent 0 is equal to 1. And for right now, I can't give you a good explanation as to why, other than just trust me for now. Once we get to, if you go actually and look through our algebra videos, when we get to something called the quotient rule, I'll show you kind of why it's equal to 1. But for now, just trust me that anything to the exponent 0 is equal to 1. Alright, let's try these together. Question's asking us to evaluate each power. So let's start at number 1. 5 to the exponent 3. So remember, to evaluate each power, we first need to write it in expanded form. So 5 to the exponent 3 means 5 times 5 times 5. Once we've broken up and expanded it, we can just do the multiplication. 5 times 5 is 25. So it becomes 25 times 5. And 25 times 5 is 125. So 5 to the exponent 3 is equal to 125. Next, with 9 to the exponent 2. Well, remember we said we could also say it as 9 squared. And that means 9 times 9, which is 81. 2 to the exponent 4 means 2 times 2 times 2 times 2. So this means 4 times 2 times 2, which is 4 times 4, which gives us 16. And finally, 156 to the exponent 0. Remember, anything to the exponent 0 is equal to 1. And there we go.